It's time for a little trigonometry review. So trigonometry means measuring triangles, and usually you're talking about right triangles. So let's just say this is angle theta. There are some useful things that we know about the sides of this triangle. Let's call this C, let's call this A, and let's call this H for hypotenuse. Let's call this O for opposite. It's the side opposite the angle. And let's call this A for adjacent. Now you may remember hearing about SOHCAHTOA. It's a way to remember how to find the sine of this angle if you know these other things, or the cosine of the angle, or the tangent. So let me show you what I mean. Alright, one thing that we can say before we get started on the sine, cosine, tangent is that if we know any two of those sides, we can also use the Pythagorean Theorem, which is that h squared equals o squared, not to be confused with 0. O squared plus a squared. So this is hypotenuse squared is the opposite squared plus the adjacent squared. So if this were, say, 4 and this were 3, you do 4 squared is 16 plus 3 squared, which is 9, is 25. That's the square of the hypotenuse, 25. So the hypotenuse would be 5 in that case. Okay, so let's look at the sine. The sine of theta, this tells us that it's the opposite over the hypotenuse. So O over H. And now, don't be afraid of this. This is a number. If you ever can substitute that in, then you don't need your calculator. You just know what it is. It's some number over some other number. In the example that I gave you, this was 3 and this was 5. So this would be 3 over 5, and that's equal to 0.6. And that's just the number. Your calculator would give you that. Okay, so don't fear the numbers. You want to get to numbers because these functions are kind of nasty. Alright, the cosine of theta is equal to adjacent over hypotenuse. That's the ca part. Cosine is adjacent over hypotenuse. And let's see, so in this case we had 4 here, and so the cosine of this angle would be 0.8. 4 over 5. Okay, the tangent, just write it down. Tangent of theta is equal to the opposite over the adjacent. You might remember from trigonometry that the tangent of theta also equals the sine of theta over the cosine of theta. Well, let's just plug that in and see if it's true. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. These are both divided by the hypotenuse, so I can cancel those out. And so I get, sure enough, opposite over adjacent. Alright, well, let's plot what happens to these functions as we change the angle here, this yellow angle. So on this part of the graph, I'm measuring angle. On this part of the graph, I'm going to be measuring either sine or cosine. Let's start with the sine. If theta is 0, then the opposite side is 0. Do you see how that would swing this arm, the hypotenuse, all the way down to the axis, and you would have 0 for the opposite. And so the sine of 0 degrees is 0. By the time theta gets up to 90, now it's just equal to the hypotenuse. And I'm going to say that the hypotenuse is 1. I said it was 5 before. It's actually easier if you use a hypotenuse of 1. Okay, so by the time we get to 90 degrees, we have the sine, actually, sorry, let me just draw this a little bit longer. All right, 90 degrees, we have that the sine is equal to 1. Because if the radius, the hypotenuse was 1, it's sticking straight up. Now the opposite is 1. It's the same as the hypotenuse, and you divide by the hypotenuse 1, you get 1. All right, so those are the two dots to remember for the sine. For cosine, when theta is 0, now the adjacent is just as long as the hypotenuse. In fact, it's equal to 1, just like the hypotenuse. And so the cosine of 0 is equal to 1. And the cosine of 90 is equal to 0. And you don't have to memorize everything in between. I'm actually going to give you a chart of these two functions from 0 to 90 degrees. Now what you would do if you were on a test and you needed to know, say, the cosine of, let's say, 60. So let's say I asked you about the cosine of 60 degrees, and you say, I have no idea, you didn't give me a calculator. All right, well, what you do, you go to 60 degrees on this graph, you find out where that intersects with the cosine, and you find out that it's exactly equal to 1/2. All right, but for any angle I give you, you can look up what the cosine is on this chart. So this is one thing that you will have on any test where you need to know sines and cosines, is a chart that looks like this. I won't tell you which is the sine and which is the cosine, but you can know by reasoning through this right here, by remembering SOHCAHTOA and then thinking about the right angle, or sorry, the right triangle, and what happens to it as you change those.